you're on. So let's do this one. I need to make this say a 0. So I'm going to use this. So minus 5x. Keep in mind this is 5x. So instead of taking it from the 2, I need to take it away from the 4x. So I get 6x squared. 4 minus 5 is minus 1x minus 2 equals 0. Now I'm going to multiply here, the a and the c. 6 times negative 2 is negative 12. So factors of negative 12 that combine to negative 1. 2 and 6, but one of them needs to be negative, right? So 2 minus 6 is negative 4. What about negative 2 and positive 6? That's positive 4. That's not going to work. What about 3 and negative 4? That gives me negative 1. Okay, that'll work. Because 3 times negative 4 gives me negative 12. 3 minus 4 gives me negative 1. So let's see. Green. So I get 6x squared. I'll move this a little bit. 6x squared plus 3x minus 4x. And then minus 2 equals 0. I'm going to factor out, what color did I use? Blue. 6 and 3. Remember, largest common factor would be 3. Oops. And then I can pull out x. 3x times what is 6x squared? 3x times 2x. 3x times what is 3x? Positive 1. I'm going to copy this. I can do that a little bit better. So 2x plus 1. And what times 2x plus 1? So what times 2 is 4? Well, that's going to be 2. 2 times 2 is 4. I need a negative 4, so I need this to be negative times a positive is a negative. And a negative times a positive is a negative. Good. Now let's rewrite this. So we have 3x copies of 2x plus 1 and negative 2 copies of 2x plus 1. This is equivalent to... I'm going to move this up here like I did the other one. Oh, I forgot to write equals 0 again. Okay, now I'm going to move this up. And write it as 3x minus 2 copies of 2x plus 1 equals 0. This is my factored form. I want to stress once again that this 6x squared plus, this 6x squared minus 1x minus 2 equals 0, and 6x squared plus 3x minus 4x minus 2 equals 0, and this one right here, 3x times 2x plus 1 minus 2 times 2x plus 1 equals 0, and this one, 3x minus 2 times 2x plus 1 are equivalent, they just look different. Okay, so I'm going to move this right. I'm going to figure out what will make this 0. So I'm going to add 2. And I get 3x equals 2. Divided by 3. X equals 2 over 3. If you prefer, 0.66 repeating. And then let's do this one, 2x plus 1. 2x plus 1 equals 0. Minus 1, minus 1. 2x equals negative 1. We end up with x equals negative 1/2, or if you prefer, negative 0.5. Oops. All right, so my solutions are, I like to keep them in fraction form. 2 over 3 and 2 over 3 and negative 1/2. Now, once again, we're going to offer some evidence that we're not completely crazy over here. So I'm going to write my original. So 6x squared. 6x squared plus 4x minus 2 equals 5x. Let's choose the 2. Let's choose 2 over 3 just to do it. And so we end up with and then 2 over 3 right here. So 6x squared plus 4 times 2/3 minus 2 equals, I forgot about this one. 5 times, yeah, that's the right color. All right, 2/3. So 2/3 to the second power. 2/3 times 2/3. I should probably put that in a different color. 2/3 times 2/3. That's 4 over 9. You can obviously put it in decimal form if you want. Just be really careful about it. The preference is going to be for fractions. Plus 4 times 2/3. Well, we'll wait for that one. Equals 5 times 2/3. So that will give me 24 over 9 plus 8 over 3. Write that a little nicer. Minus 2 equals 10 over 3. Okay. So I'm going to rewrite this as 24/9 plus, I'm going to multiply this by 3. That's 9ths times 3 is 24. Minus 2 equals 10/3. So 24, so that's 54/9. I mean, what am I saying? 48/9. Woof. 48/9 minus 2 equals 10/3. And I'm going to rewrite this. So 48/9 minus, that's how many ninths? That'll be 9 and 18. Like I said, you probably would prefer to try your hand at the decimal version of this, which is fine. And then 48/9 minus 18/9 is 10. Well, what am I saying again? 30/9. And then I reduce this by 3. I get 10 over 3 equals 10 over 3. Like I said, you could turn it into decimal, and I think part of the reason why I gave you options is because if you have thirds, you would probably just use this half instead, right? Like if you have this half, it's probably better than putting 0.33333, the whole thing. I just wanted to show you that it works. And be careful. The proof sometimes will say 2 solutions where you prove both. I just didn't want you to do that on every single problem. So some say prove one of the solutions, or either one, and then some say prove both of the solutions. All right. That's it. Thank you.